What a doozy. A huge windstorm just swept through China. Let's go to our Fort correspondent Evelyn to learn a little more about wind forces.
Wind is one of the nature's greatest hazards to life on our planet. The act of this natural phenomenon is sudden, with little or no changing to make preparations against damages and collapse of structures or buildings. Wind moves mostly horizontal direction from an area with high pressure to an area with low pressure, and the intensity of this pressure is wind load. And it generally acts perpendicular to the surface of building. The load is various depending on the geographic location of the house, its height, and its roof pitch. It has the most significant impact on roof framing, overhangs, and large openings. There are three types of wind load: uplift load, shear load, and lateral load.
Evelyn. We lost her. We're having some technical difficulty, so I'll pick up on uplift. Uplift is when the pressure on the inside of the building exceeds the pressure on the outside of the building. Small structures are more susceptible to this. 1, because of surface area. 2, lightness. 3, their foundation does not reach as far, and they have external structures that trap wind more easily, like porches. Wait, Dargo, is that you? Oh, let's go back to China for some more.
Then we'll talk about the wind load for tall buildings. The lateral forces from the wind load act horizontally and sometimes outward. It can cause building to sway back and forth. With increased height of building, the construction cost per unit area will decrease, and the lightness in weight per unit area will increase. So there will be more danger against a high velocity of wind force at high level. Under the wind load system, the walls of the building could be divided into 3 types. The wall facing the wind is called the windward wall. The opposite one is called the leeward wall, and the other 2 are called side walls. The pressure keeps constant in both the side walls and the leeward walls, and the pressure varies with the height in the windward walls. Near the Earth's surface, the motion is opposite, and the wind speed reduced by the surface friction. So at the surface, the wind speed will be reduced to 0 and then begin to increase with the height. And a graph of the wind velocity with the height should be like this. So the building must be carefully designed to resist wind load.
Wow, Dargo, really exhilarating stuff. Now we know about wind forces on small buildings as well as tall. Let's learn a little bit more about the variables. Now to you, Zach. And it's rolling.
All right. A few different variables affect wind pressure and its effect on buildings. The first of which is building shape. A building's slope, ratio of height to width, and the ratio of width to length of the building have a great effect on the amount of pressure caused on the windward side of a building. This affects the amount of pressure on the leeward side less than it does the windward side. Shape details such as chimneys, parapets, and spires can create a greater effect on pressure distribution, but there's no formulaic way to determine this. The best way to do so is through model testing, where they build a scale model and test it in a wind tunnel. Another factor affecting wind pressure are the openings. The size and location of openings, such as windows and doors, have a great effect on the internal pressures. The next of which is wind direction. The orientation of a building has a great effect on the amount of pressure distribution. This is particularly evident on the leading edge of a building, where the orientation and the amount of wind can cause suction. The next of which is an increase in wind speed based on with the height of the building. Due to an increase in wind speed and pressure, as height goes, a height factor is applied the taller the building is, which helps account for the basic pressure in a building. For example, if a building is 90 feet tall, the height factors that apply are 0.8 for the first 20 feet, 1 for the next 20 feet, and then 1.2 for the following 50 feet. Shielding also has an effect on the pressure distribution over a building. An example of this is landscaping or surrounding buildings, which can positively affect the wind pressure on a building. It can help mitigate some of the wind, but it can also have a negative effect where this is affected based on the distance from building or the landscaping from the building, which can cause pockets of pressure, which can also cause higher wind pressure. A couple different methods of resisting these wind forces. Let's see, dome homes, because of their round shape, prove to be more aerodynamic, which help to kind of send the force over the top of the building, which kind of helps distribute it so there aren't any flat faces that are taking that force. Hurricane ties help to tie the structural trusses to the top of a wall, which help with preventing against uplifting. Hurricane doors and windows, which are rated to a particular wind speed, can also help because these are particularly susceptible to wind. And when these fail, it can cause a increase in internal pressure, which will then cause the roof to fail.
So first, we can understand this. Higher the wind velocity is, lower the air pressure is, and the wind will flow from the higher pressure to the lower pressure. So let's take a big skyscraper as an example. So here we have a big skyscraper and the wind flow from this side. And let's take a top view from it. And here is a plan view of the building, and the wind flow from this side. And as soon as the building hit the front side of the building, of course, the wind cannot go through the building, and it will go surround it like this. As soon as it get back side of it, it will go back as they had before. So these two sides of the building will create a positive force and a negative force. Let's take the front side of the building as an example. So it feels like a people hit the building with a big water ball, and it create a big pressure at this side, which is a positive force. As for the back side of the building, so as we talked, the higher the wind velocity, the lower the pressure is, and the wind will flow from the higher pressure to the lower pressure. So which create a negative force at the back side of the building. So let's go back to the sections. So this positive force and negative force is the two main factors. And these two forces with the resistance created by the structure, which will create a shear load. And this, only think about this positive force, it will create a lateral force at this side. And as for the top of the building, just like the back side of the building, the wind will flow from the higher pressure to the lower pressure, which create a lateral force. So these are three different forces: uplift force, lateral force, and shear force, and the reason behind it.